Hi everyone, in this video we're going to look at a binary search to try to find a flavor in the gelato flavors array. The linear search, which we've talked about in previous videos, is fine for a small array such as this one, but if you're dealing with a much larger array, then the linear search is not efficient. The binary search is much more appropriate. So the binary search is probably overkill for a tiny array such as this one, but we can still do it just to learn the concept. So basically, we're looking at a picture, kind of a visualization of the array, and I've color-coded it into like halves, two different halves. Oh, and very importantly, notice that the contents of this array are in alphabetical order, or they're in order, and that's a prerequisite for the binary search to work. So your array has to be sorted, and these are sorted alphabetically according to flavor name. So basically how this works is your algorithm starts by finding the midpoint of the array. Now there is no element that is the precise midpoint of this array, but this right here, hazelnut in this case, is going to be determined to be the midpoint of our array. Once we just divide the number of elements by 2, and then the decimal is going to be truncated. So we end up with hazelnut as our midpoint. And so our algorithm is going to ask, first of all, I think we're going to be searching for chocolate in this example. So our algorithm is going to ask, is hazelnut greater than or less than chocolate? Well, first it's going to say, is hazelnut equal to chocolate? And no, we didn't. Sometimes you might get lucky on the very first try, but probably not. So then it'll ask, is hazelnut greater than or equal, or greater than or less than chocolate, basically. And if hazelnut is greater than chocolate, greater than our search term, then we're going to repeat the whole thing, but focusing on this top half, okay? Or else, if that weren't the case, if we were looking for pistachio or something, and our search term was greater than the midpoint we first came upon, then we would refocus our efforts to repeat the algorithm, but only focusing on this bottom half, this green part. So what you're doing, so then the thing starts again, and I find the midpoint. Now it's much more clear when we have 5 elements. Now we're only dealing with the orange. Is chocolate equal to coffee? Coffee becomes the new midpoint. No, we didn't get lucky this time either. So if chocolate is less than coffee, which it is, alphabetically speaking, then we're going to redouble our efforts, focusing on the top part of the array, probably just these 2. And or else we would focus on the bottom part of that new search area. The green is out of the picture. We eliminated that, and that's why this algorithm is so efficient, because you're eliminating huge swaths of the array right off the bat, and just zeroing in by making your area of interest smaller and smaller and smaller, having that area of interest every time. Okay, so let's look at the code. All right, so all of this stuff is the same as we've had in the linear array, so I'm not going to really focus on that. We have the max flavors, there are 10 in this case, a Boolean for whether or not it was found, and if it is found, then we'll capture that found at index. Now this, let's not even talk about this. I told you that the array has to be sorted in order for this algorithm to work, so that's the line that sorts the array. It's kind of a bit a cheat, especially for this class. We will look at sorting algorithms later, but I just did it like kind of a quick and easy way using one of the library functions. Okay, so here's the algorithm. I'm creating some variables for our binary search algorithm. We have int first and last. Now I just hard-coded these values just for the sake of simplicity of the code. You probably would do max flavors -1 or something here with the last. But let's just hard code these values. So these represent our starting point for our end, starting and ending points of the range of interest for our search. And I mean, the first right off the bat, the first time through, we are concerned with the whole array. 0 through 9 in this case. So that's why I used 0 and 9. And then we have just a variable called midpoint, which is going to be determined, the value of which will be determined in just a couple of lines. So we're going to keep doing this algorithm, or keep looping, while the value is not found, and while first is less than or equal to last. Like, there may be a point, if you're just not lucky at any turn and you're not finding that value, there's going to eventually be a point where the area of interest becomes smaller and smaller and smaller and smaller, to where there's no more range left. You're just kind of whittled down to nothing, and that's really what this is determining here. And then if that's the case, if you're down to the point where first is equal to last, and you're looking at the one element, and what you're looking for is not in that element, that item is not in the array. Okay. All right. So anyway, here's where we determine the midpoint, just by adding the first and last, and then dividing by 2. Okay. So that'll cut the array in half, or the area of interest in half. Again, the first time through, the area of interest is the entire array. And then it's just a simple, like, if else structure. We're saying if that flavor at that midpoint, I think hazelnut is the midpoint this first time through, is equal to what we're looking for, chocolate. Okay, well, that's not true. If we had gotten lucky, great. We found it, found is set to true, and then the found at index is that lucky midpoint. But more likely, we're not going to get lucky on that first try. So we're saying, okay, if that value in the midpoint is greater than what we're looking for, now we're zeroing in on the kind of the upper half of the area of interest here, which is the orange part here. So really, that's an easy thing to establish. We'll just say the new last, it's no longer number 9, we no longer care about the whole thing. The new last is going to be the midpoint minus 1. So now first is 0 and last is 4. That shifts the focus onto just this orange part. And now we're going to repeat the whole thing. And midpoint becomes coffee. And we're going to try to see if that's the search term that we're looking for. Okay? Or else, then we shift to the bottom part of the array. Shift to the bottom part of the array by saying midpoint, the first index in the range of interest is midpoint plus 1. You see how that would shift? The first becomes midpoint plus 1, which is peppermint in this case. And then the focus goes to the green part of the array, and we've eliminated the orange part in that case. So if it's found, then we'll display that to the user. So I'll just go ahead and run this. We know what's going to happen here. Looking for the chocolate. Oh, shoot. And there it is. Found at index 1, which is the second element in the array. So there's your binary search.